This is the exercise that involved the inventory buffering, and what I'd like to do is to create this template in Excel that allows me to solve this problem with the ability to change the fill rate and whether or not the demand is perfectly correlated across weeks, because in my problem I'm asked to change those values within in parts A, B, C, and D. And I should mention that it's kind of hard to develop a completely generalized template for this in Excel because the number of periods will be different, and it would just be a little, I would say, awkward to have something that was very um, generic. So I'm going to have to customize this for each problem, at least to some extent. So in this case, because I know that I'm dealing with a review period which is 2 weeks and uh, and a 1 week review, I'm sorry, a review period of 1 week and a lead time of 2 weeks, I know that I'm going to have to look out 3 weeks to look at the mean demand and the standard deviation of demand, etc. So I'm going to start out here by looking at the some of the main inputs here. The coefficient of variation is stated to be 0.25. Fill rate I'm going to allow to be in the step-by-step procedure to be changed. I have inventory on hand of 1279, and I have pipeline inventory of 2098. And then I'm going to be changing whether or not the demand is independent or not. So independent across weeks. So what I'm going to do is I'm going to make this 1 equals yes, 2 equals no, or should say 0 equals no. So I'm going to put a 1 or a 0 here, depending on if the answer is yes or no. And part A of the problem is perfect correlation, so I'm going to put no, they're not independent. Now, I have the week 23, 24, and 25 forecast. So let me actually move these down. And I'll put up here the forecast. I'll just use FC, and I'll put the standard deviation. So the forecast is equal to 500 units for the week 23. Let me make all these centered. 1,000 units for week 24 and 1,500 units for week 25. And of course the standard deviation is 25% in each case, so I'm going to use that number, put a dollar sign in front of the 1 so I can copy this down. Alright, now over here I'll do the step-by-step procedure for my inventory buffering. So looks like I have got a subscript in there as a default, so let me just take that out. So step 1 is to calculate the mean for period T plus L, and so here I want to make this M equal to mu, so I'll make it a symbol, and I want to make the T plus L a subscript. Alright, and I'm going to also need the sigma value, so I'm just going to copy that down and change the M to an S, which in Greek is sigma. And I'm going to need the CV of T plus L. So here I'm actually going to make CV, but I don't want that to be in Greek letters, so I'm going to take that and make that back to my default font. Alright, so the mean value is equal to the sum of the 3 forecasts. Now here's where the standard deviation across weeks depends on if you're perfectly correlated. And if you're perfectly correlated, the signal would be there's a 0 here, then you sum the standard deviations. So I'm actually going to make an if statement. So I'm going to say if this value is 0, then I'm going to sum the standard deviations. And just to get a little ahead of myself, if they're not if this value is equal to 1. Then what I'm going to do is I have to do the square root of the sum product, because it's the squared values of this comma this. So remember that what we're doing is we're taking the square root of the standard deviations squared and adding them all up. And I'm not going to get too fancy. I could say otherwise print an error message because I don't get a 0 or a 1, but I'm not going to bother doing that. So I think I just put one more parenthesis, and I got too many arguments. Let me just see what I did wrong. So if B14 is 0, do this. Oh, this should be an if statement. Otherwise, if B14 is 1, do that. Let's see if that works. Oops. B4. Alright, so I'm just going to go look at the formula. I think it's okay. So we have that value, and then the coefficient of variation is that divided by this. Now I know with perfect correlation I should end up with 25% because I won't have a reduction in standard deviation across time periods. Step 2 is to specify the fill rate, and that's going to be an input. And for the first analysis we're doing here, it's 0.99. That's something that will change. Step 3 is to calculate f of k, and that's equal to 1 minus the fill rate divided by the coefficient of variation. And remember, from doing the capacity buffering, in order to do the table lookup, we're going to have to round this off. So we're going to round this off to 3 decimal places. Alright, and I'll just show it as 3. You see it's rounded. Step 4 is to find the value of k from the table. Alright, I'm going to take a little break here, and I'm going to get the table, and when I return you'll see the table has been loaded into this spreadsheet. I forgot to do it, so hold on. Okay, so you see here that the k table is there, so I'm going to do a lookup, and just to be safe here, I'm also going to do that little check to make sure that the value of f of k, if it's above 0.4, then I'm going to put the value 0. Otherwise, I'm going to do a VLOOKUP of f of k, comma, go to this table, and from row 2, column 2, I'm sorry, I want to grab the value. So as a check, 0.040 should be 1.36. .040, 1.36. Okay, good. At least that worked. Then step 5 is to calculate the safety stock, which is equal to k times the standard deviation sigma. All right, and so that's 1020. Now that's the procedure for getting the safety stock. In our case, we're going to continue this by looking at the order up to level, which is equal to actually I'll put that over here just to line it up better, which is the safety stock plus the mean value, and then the order quantity, which I could use the value Q, and the order quantity is equal to the order up to level minus the inventory, which is I'll put a parenthesis, which is this value here plus this value here. And I'm just going to think ahead here because I may get a value less than 0 here. So I'm going to say if the order up to level is greater than this plus this, then, comma, I'm going to put that number, which is the one I just calculated, because that means I'm going to place an order, otherwise I'm going to say 0. And I could have done this a couple of different ways, but I'll just do it that way. All right, so we get a number of 2532. And we just double check. Oh, that pipeline inventory is wrong. Instead of 209, it's 2089. So the order is 652. Oh, I'm sorry. This is 2098. All right, so it's 643. And that's what it says in the module. So I'm going to just highlight a couple of these things as the results here that are important and the key inputs here for doing this problem with this one and this one. Because once we set this up and we've taken precautions to make sure, the FR is, the FFK is above zero point 0.4, we're dealing with that. We have independence versus not independence perfectly correlated, in other words, and we also check to make sure that the order quantity is positive, otherwise we make it 0. Let's see what happens in part B of this exercise, where the target rate is reduced to 98%. So we just change this to 0.98. We see the results. Now I see that I'm going to just show these as rounded numbers. We see now that the order quantity is, the order up to level is 3766, and the value of Q is 398. If I'm going to run the scenario where I go back up to 0.99, but we have independence across, and by the way, whenever you're doing something like this, it's a good idea, it's almost like a sanity check to say, okay, if we're going to have independence, that means the standard deviation will be lower, which means the buffer quantity should be lower. So right now, you notice the buffer quantity is 1020, now it's 531. And the order quantity is 154. And then finally, if I make this 0.98, we get a buffer quantity of 357 and an order quantity of 0, because the current inventory plus the pipeline exceeds the order up to level, so we have a 0 there. All right, so that's how we do the inventory buffering for a single product using a fill rate target and having the option of correlation across periods versus independence across periods.